everyone and welcome back to my channel Lessons at Fingertips. Here we discuss on some important topics in very simple words so that it's easier for you all to understand and keep things in mind. Today our topic of discussion is going to be Axioms of Indifference Curve. Now you need to understand what are the Axioms of Indifference Curve and where from is it coming. Why do we even need to study that? You see, we have already discussed that utility from any commodity can be either measured in terms of utils, that will be the cardinal approach, or you can even use the ordinal approach, which will be in terms of preferences. What is preferences? If you have a lot of bundles of commodity, based on the units, based on your preference, which commodity you like more, you are going to rank them, isn't it? So this ranking of commodity on the basis of utility, on the basis of choice is called preference. Now to understand the preference, we use what? The indifference curve. Now before you study indifference curve, you must know three important axioms of indifference curve. Now the first one here we go for the completeness, axiom of completeness. Now what does that imply? Whenever a bundle is preferred to B, suppose a bundle is A, another bundle is B, okay? So if A is preferred to B and B is preferred to C, B is preferred to A, then we can say that A is indifferent to B. That means what? Suppose you have a commodity, suppose A is a commodity, B is another set of commodity or bundle if you are choosing two different bundles. Now if bundle A, you are preferring bundle A to bundle B. Again you are saying that no, it's okay if I get bundle B than bundle A, okay, in place of bundle A. That will also do. That means what? You are indifferent between bundle A and bundle B. मतलब कि कोई भी चलेगा, ठीक है? So preferences are complete if for all bundles A and B, if A is preferred to B or B is preferred to A, or A is indifferent between or both, you see, that means what? Indifferent between A and B. Consumer can always compare two bundles, that is if A is preferred to B and B is preferred to A, then A will be indifferent to B. Okay, so either you are going to choose a particular set of bundle, or if you are choosing both of the set of bundle, then we will say you are indifferent between both of the set of the bundles. Got it? So either you will say that I prefer A to B, or you might say I prefer B to A. But if you are saying both, that means you are indifferent between A and B. Got it? This is the completeness. Next we have what? Transitivity. What is the term transitivity implies? This axiom states that if A is preferred to B and B is preferred to C, that means A will be preferred to C. So suppose we have four bundles, okay, that is A, B, C and D. Now if I say that I will prefer A to B, I will prefer B to C, and I will prefer C to A, isn't it? That means what? You see, if B is preferred to C, that means A will be preferred. So here, if I say A is preferred to B and B is preferred to C, okay, that means what? And C is preferred to D, that means what? A will be preferred to D. Got it? मतलब D को I am putting in the last. Okay, if I am said to rank this, then I will rank A at the first, B second, C third and D fourth. Got it? So for this ranking, the axiom of transitivity plays an important role. Okay, this shows that the consumer is consistent. The consumer is consistent at A. मतलब कोई भी bundle में से out of this four bundle, if you give me bundle A, then I will be the most satisfied because I am preferring A to any of the bundles. Got it? So this is the transitivity axiom. Next we have what? Non-satiation. What does that imply? More is better. मतलब कि more and more commodities if I am given, that will satisfy me more, isn't it? So जितना ज़्यादा होगा, that much is better. So this axiom states that preferences are monotone. What does that imply? You see, if I have taken a bundle A, okay, which is x and y, bundle B is x dash y dash. Now, if I am saying if x y is greater than equals to x dash and y dash, then we can say that A is indifferent to B. Why? Because यहाँ पे we have greater than equals to. So I can say is A is indifferent to B. But if I am strictly given that bundle x y is greater than x dash y dash, definitely I will prefer bundle A to B because more is better. जितना ज़्यादा होगा उतना ही अच्छा है. Got it? So this is the axiom of non-separation. Now when we go through these three axioms, we come to the conclusion that two indifference curve is never going to intersect each other. Why? You see, whenever you see, this diagram is very important. Suppose I have taken two indifference curve IC1 and IC2. Got it? Now I have taken three different points on these two ICs. One is on IC2. The second one is the intersection point between IC1 and IC2. And the third one is on the IC1 curve. So you can see that A is in a higher position than C. Definitely A will be preferred to C. This we know. A will be preferred to C. है ना? Now you see, if I compare these 2 points, यहाँ पे क्या पता चलेगा? That A and B will be indifferent. A is indifferent to B. Why? Because they are on the same IC curve. Same IC curve may will give equal level of satisfaction. Along an IC curve, the level of satisfaction will not change. So, in the same IC curve when they are lying, B to same ही में है ना? We cannot understand if it's in IC1 or IC2 because it's in the intersection position, isn't it? So, A will be indifferent to B. Again, if I take 2 points B and C, then again I will say B will be indifferent to C. B will be indifferent to C. कोई भी चलेगा because they are again on the same IC curve. So now you see, if A is indifferent to B and B is indifferent to C, then as per the transitivity axiom, A should be indifferent to C. But is it true? Is A indifferent to C? We already know that A is preferred to C. तो यही पे आ जाता है the problem. That's why we say that IC curve is never going to intersect each other. Two ICs will never intersect each other. ठीक है? ICs are always going to be parallel because whenever they are intersecting implies what? They are providing the same level of satisfaction. तो ऐसा नहीं होता है. Higher the IC, higher will be the level of satisfaction. This is a property of indifference curve, isn't it? Now there are two things which cannot happen. Two IC curves are never going to intersect each other. IC curves are never going to touch the axis. None of the axis, IC curve will never touch the axis. Why? Because whenever an IC or suppose a curve is touching the axis, okay? Suppose here is the IC curve, it's touching the axis. What does this point implies? That x is suppose 10, y is 0. So this can never happen, okay? Both of the commodities ka kuch na kuch you will have to utilize. That means what? You only want commodity A, X. Suppose there are two commodities, X and Y. So this point on the IC will say what? You only want commodity X. This point of IC IC curve will say what? You only want commodity Y. So this is never going to happen. In case of IC, in case of a consumer satisfaction, if you are stating there are two commodities, दोनों commodity का mixtures you will have to say. ठीक है? दोनों commodity का you will have to mix and then say. Not that एक को 0 बैठा दिया और एक का maximum ले लिए. No, they will not show you any of the extremes. You cannot choose extremes in case of the IC curve. Got it? Now, when we study this, you see, here we see I is indifferent to A is indifferent to B, lying on the same IC curve, that is IC2, and C and B are indifferent because they are lying on the same IC curve, that is IC1. So A must be indifferent to C as per the transitivity approach, but that is not true. Here A is preferred to C. Why? Because A is lying on the higher IC curve than the C point. IC2 is on the higher IC curve, isn't it? So if IC intersects, it violates the axiom of transitivity. Got it? So I hope you have understood till here. These were the axioms of indifference curve. There are certain properties of indifference curve also we will discuss in my later videos. Thank you. I hope you guys have liked this video. Please do hit a like and subscribe to my channel. Share it with a friend and do subscribe. Okay, don't forget to subscribe. Okay, till then, bye bye.